This is the SIG network meeting for March 3rd, 2022. Forgot to ask, do we have anyone lined up for a round of issue triage?
I have it.
This is his hand. You should be able to share now. I had forgotten to toggle the.
Give me a second. Share. Window. Okay. Right. So I appreciate everybody who ran through today and pinged bugs and closed out old issues. We have exactly one issue for triage, and actually it's barely here for triage. Rob, are you here? Okay, well, this issue was a user who's doing something interesting, trying to put their own annotations and finalizers on an endpoint slice. I think everybody on the thread has disavowed him that that's a good idea. The question that is open is, do we actually cover that in tests? What happens if somebody puts a finalizer on an endpoint slice and the controller fails to delete it or thinks it's deleting it? Does kubeproxy keep those endpoints? Seems like a really good corner case to make sure we have covered in tests. So I'll leave this open. I ping Rob as the endpoint slice person, but if he wants to open a new issue or something, that's fine. We'll leave it open to decide that. Anybody want to discuss this one? Seems pretty straightforward to me.
Is that true, that the finalizer is overridden?
So that I'm surprised. If that's true, I'm surprised. I mean, somebody had to write code to like clear the finalizer explicitly, which I don't think would happen. So my guess is if you put the finalizer, I haven't gone and tried it yet, but if you put a finalizer on an endpoint slice and then you delete the service, that the slice will stick around until the finalizer is removed, which is what I would expect to happen. But I'll bet that it might confuse kubeproxy, maybe the controller too.
No, kubeproxy is, if there is no service, there is no problem.
Sure, but if I have a service with two slices and I delete one of them, it might very well keep those endpoints around, because I'll bet that kubeproxy doesn't bother to look at the deletion timestamp. Like it doesn't consider in process of being deleted.
I don't know. I don't know.
I can't help but feel like we're missing some hooks or something in the watch client that makes it really clear, not just it's been updated, but it has, the deletion process has been started, and that's different from an update that sets the deletion timestamp.
The common
No, we don't do that.
I know we don't. I'm wondering if we should.
The common pattern on the update hooks is to check if it has a timestamp. So it means that it's been deleted, and people try usually.
But it seems like the sort of thing that everybody will forget because it's not an explicit hook. Like it seems like there might be an interesting opportunity to provide a delete hook or, you know, delete started hook so that the client could capture that as a distinct, like just so that in documentation, when you look at it, that's a distinct thing from a plain old update. Like it's an important difference. I don't know. We don't need to discuss it here. It's just something that crossed my mind of like how many controllers out there will sort of do the wrong thing if somebody puts a finalizer on a resource that isn't expected.
There is another common problem with the way client works. So I don't think it's the client problem, but it's in all controllers. Everybody on update, they start doing their dance, right? The problem is on update doesn't mean a field that you're operating on has been updated. So a common example is updating annotation, updating labels, triggers, resynchronization all over the place. Even the default controllers that are part of Kubernetes does not really do that in most places. So that's also something I've witnessed over the places. There's no way you can ask the controller, tell me if this field was updated or those fields were updated, and nobody does the sanity check of, oh, I have old cached version, is it different or not? So yeah.
Yeah, I
hear you.
mean, maybe these are things that we should build into the example controllers more completely, right? Like first, here's a filter process. Does this update apply to me, right?
Yeah.
If this update is delete, call a different hook. If it's not applicable, just toss it in the cache and leave it alone.
I missed the start of this conversation, but is this related to the bug that is okay?
That's
That
the one.
annotation and finalizer on an endpoint slice that's managed by endpoint slice controller.
That's right.
I'm very confused by this use case.
Sorry, you missed the intro, which was, I think we've disavowed this person of the idea that this is a reasonable way to use it. But I don't know if this is covered in test cases. I don't know if kubeproxy and/or the various endpoint slice related controllers will actually kind of go crazy if you put a finalizer on a slice. I wouldn't be surprised if they do, and I tagged you on the bug to say, hey, Rob, we should maybe put this into the tests.
So a finalizer on the slice would prevent it from getting deleted.
So would kubeproxy keep it around?
Yes.
Is that the right thing to do?
I mean, yeah, it feels like someone trying to do something they shouldn't do and getting and their things breaking when. But yes, we should have a test. I don't know what can we do? Can we I would
kubeproxy would ignore it. I think when we receive that update and we see the deletion timestamp set, we should just ignore that slice from then on.
Fair.
But the problem, if the slice doesn't have a service, you don't have a problem.
But if you have a service with multiple slices and you delete a slice, then you will keep those old endpoints around, right?
Okay.
Like the endpoint slice controller has this rebalancing logic at some point. When you hit a threshold, it'll pull all the endpoints out of one slice and put them into the other slices in the empty spots, right? Something like that, right, Rob? And then it'll delete one of those slices. The question is, if it doesn't clear the slice, if it doesn't like empty the slice, but it just deletes it, it seems like it should work. But if somebody put a finalizer on it, will those IPs, I just don't know what'll happen.
Yeah, and if it's pending deletion, I think it would still show up as an existing endpoint slice, which means our controller would try to potentially add endpoints. I don't know if we have a check on deletion timestamp in the controller itself. So I can see, it's an unexpected input to the system, but we should.
Yeah. Exactly. In fact,
if they're adding this, it's because they
so Tim, and what you're describing,
stay active during the deletion process, right?
Right. In fact, maybe the API should just reject any updates once you've got the deletion timestamp set. Do we reject the endpoint updates? Okay, that's good.
Tim, and what you described, right? It would have the same object occurring in two slices in worst case, right? Because it was not properly removed.
Sure, but I bet you could, if this were to trip up the controller, I bet you could synthesize a situation where you could crash the API server or something.
Oh, no, sort of, the semantics needs to be tightened up. That's what you're saying.
Yeah.
This seems like the sort of thing where the controller ought to be able to say, nobody is allowed to put a finalizer on this object because it's my object and I don't want them to.
We need nice
to deal with this anyway, but.
Right.
You're asking for a lot of pain. That's a lot of pain, right?
It feels like a escalation of conflict here, right?
Mine.
But I mean, how many other controllers have exactly the same bug right now?
I bet more than one.
True. I do have a thing about what you just said, Tim, about finalizer. I don't think we should react until the thing is deleted, because you don't never know that the finalizer is there to do some pre-cleanup, right? Somebody needs to do somebody said, do not remove this object until I do some prior cleanup. We are not in a position to say exactly what is this. So acting on the fact, aside from what Dan just said, which I somehow see where it's coming from, I actually been thinking about that. Like has to be a way where we say, these are mine. You cannot touch them. But commenting on your earlier comment about we should do anything when we see delete timestamp, we don't know if somebody depends on the fact that this object exists, or in a way, we don't know if somebody depends on the fact that there are endpoints, the system routes to, and everything works until this person decides that it's okay now, clean up.
The semantics of finalizers are you can prevent the resource from disappearing from etcd, but you're not allowed to assume that it continues working just because you have a finalizer, are you?
That's right. No, it like the semantics of finalizer is exactly what you said. It's dead. That object is dead the minute you delete it. Just you're waiting for everybody else to figure it out. So I'm going to disagree with Cal, but we can take it to the bug. I think first step is, Rob, go see what happens, or see if it explodes.
Yep, we'll do.
And this might be a fun one to bring back to, like, I don't know, SIG Arch or API machinery or something, like, hey, this is a problem that probably exists for other people. Is there a pattern that we could use to solve this? Right.
It would be
or we just start writing a book.
Yeah, it would be very nice if you had some kind of guarantee that I own this resource and no one else can touch it, like others have referred to, because
I mean, you could delete it. You could delete it in the controller and just clear the finalizers list unilaterally. That sounds like a terrible idea, but you could do it.
I mean, maybe not so terrible if it's managed by yeah. Anyway.
Yes, you're juggling very sharp knives right now.
Yeah.
Well, that's it for triage.
Yeah, wild turn of events. One issue has filled up the full 15 minutes of triage. I'm going to shuffle up the agenda a little bit because I know that Dan Williams needs to leave halfway through, and his is last. So let's pull that to the top and quickly talk about the SCTP.
Tricked you, Dan.
Clearing.
Yeah, I know. I was about to say, let's, if we don't get to it, that's fine. But no, the issue came up the other day because we were looking into some bugs that we had. And it looks like kubeproxy treats SCTP contract the same way as it treats UDP contract. But that seemed a little wrong because SCTP is closer to TCP. And so I guess the question is around.
No.
There's been a lot of change in this area, I think, in kubeproxy. And Antonio, you've been looking at some of that over the past year. Is that my read of this correct? And is that the right behavior, do we think?
So the code that is now, I was cryptocurrency because there was a method that say contract needed or something, and SCTP was there, and I'm an ignorant on SCTP, so I carry over with that. But then there was another bug, and I was checking with one person at Red Hat in the net filter code, and the contract net filter code checks the session. So the kernel should be able to track the session and clear the contract entry. So he fixed the bug, and my understanding is that we shouldn't clean the entries.
So Per was the first one to say, I think it was Per who said no.
Yeah, so I mean, so the problem with SCTP is really that it has this multiple endpoint thing going on, right? That you can set two addresses that is supposed to go to the same state. And the many applications require that you have that set. SCTP is a very, I mean, Lars is here as well. He has a lot of opinion on SCTP. When both SCTP and multipath TCP is very tricky to implement through a contractor, because you need to go and read what happens inside the protocol. You cannot get all information just from what comes in the TCP. I mean, in the SYN that you get, or in UDP for that matters, that you have the 5-tuple. With both multipath TCP and SCTP, you have additional information that is carried in PDUs when the first sort of session is set up. They're very tough to treat properly.
Yeah, but on services we only publish one IP. I mean, I'm naive on SCTP, so I'm just saying what I learned during the past. But in this case,
I agree.
One IP. Go ahead, Matt.
I don't think multi-homing is an issue to be considered because it's not supported in Kubernetes. But One important fact is that very many SCTP clients binds to a certain port. TCP clients never do that. They use the ephemeral port. But SCTP clients quite often binds to the same port and it reuses it for reconnects all over again. And I believe it would be the same problem with TCP if people did that, but they don't.
Well, TCP, you have the time weight and well specified and close weight, right? So the local stack will take care of it to make sure that you don't even try to set it up; it will block it there. But yeah, I mean, you see, we have a couple of UDP test examples, right? When we that binds the client port.
Yeah, that's common in UDP, and it's unfortunately common in SCTP also.
Does that answer the question at hand then? Do we need to keep SCTP contract logic or fix it?
It sounds like we should add TCP tests that explicitly bind the source port, because we know that the bug report involves people binding the source port. So maybe we should just add TCP tests that do that and see if it works with the existing code. And if it doesn't, then figure out what we need to do to make those work without breaking anything else. And then that should work with SCTP too.
The local client should stop you from doing it the second time, right? You should not even get to the service.
No, so the issue is something like,
it was a service deletion, right, Dan?
yeah, it's like the client is connected to the service IP, the service backend changes.
Yeah.
No, it was like
I forget the details.
They deleted the service and then recreated it and expected it to either, I forget which one it was, not work or work, and it was doing the opposite of what they expected. And we were like, we're not sure what is expected upstream, like what should happen in that case.
Maybe we should make sure that the SCTP experts are CC'd on this issue.
Probably. I mean, in general, though, what is our expectation if around draining a service? So if you have a connection from a client through a service to a backend pod, and then you delete the service itself, what should happen? Do we expect that connection to exist until the actual pod itself goes away? Or do we expect that when the service is deleted, that all connections to any pods backing that service are dead?
In TCP, you mean?
I'm saying in everything, really.
Well, the answer is different for TCP and UDP, right?
Yeah.
No, not necessarily.
No, it should be the same.
Service, is it a type of firewall rule that you remove the service, then you should tear everything down, right?
No,
if you say that you should continue the service that's ongoing.
So this is based on the concept of session. So you don't break the session that is established. And in UDP, you don't know. You just, and we are.
No, it's the same in both. If you think about it, as a control plane, you're saying, I am no more interested in routing traffic that way. Existing traffic should immediately be killed. The fact that it takes seconds to do that.
I agree with you in a hypothetical, but in practice, with a TCP session, I can't like break the link and then stick something new in and start intercepting traffic. With a UDP session, I can. So I think the correct answer is different depending on whether it's UDP or TCP.
The other question I had was, how do we gracefully drain a service? Is that where you keep the service around, you kill all the pods to that service in the back end, and then you delete the service? Or like, how do you stop accepting service traffic, but then allow existing connections to gracefully age out?
You kill all the pods, but they have termination, grace, whatever. Okay. And because they're terminating, the endpoints go away. And because the endpoints go away, the service stops accepting new connections. But we don't delete the contract entries, so the existing connections stay there until the pods finish them and exit, or their grace period.
Okay. But currently for SCTP, we do delete the endpoints or the contract entries when the endpoints go away.
Yes.
But that's there because we were carrying over with the UDP. I mean, it's I don't know how this started.
The reason is simple, right? Because if you have something, so with UDP, there is, SCTP is a little bit different, but UDP, there is no guarantee that you have traffic coming back the other way. So you have unidirectional UDP streams, which means that you can have something sending and it will never know that the service is gone. So there's nothing then that can recreate the stream because the contractor already have an entry in there. So you need to delete that entry. But going back to the first one, so I mean, if you say that the service should, for the execution flow should continue, and then if you want to have them removed, right, that you will do with a network policy entry then, right? You will remove the ability for these two objects to talk to each other, and then you would have to clean up the contractor. It's really, but
I'm not sure we have a well-specified enough question here.
no, so but
Yeah, I mean, I guess my question is the current behavior we have for clearing SCTP contract on endpoint deletion correct? That's the basic question. And then I guess the other question I had about service draining is more general. And
the answer there is, does the contractor handle SCTP? For TCP, right, you will get the reset sent back. If the endpoint is gone, you will get the reset sent back, or you will give up because you don't get ACKs back. So the stuff will clean itself up after, well, can be minutes or hours depending on what's there, right? But if you have a unidirectional stream like you can get with UDP, the sender can keep on sending. There's no receiver, and there's no way that the infrastructure will tell him that there's no one receiving this anymore. There's no NAC or anything going, right? For SCTP, there is state control. So there needs to be something that goes back and sort of say the equivalence of a reset, right? To say, this is not there. Does the contractor react on that? And in that case, clean up the entry.
Does this get more complicated? I mean, with user space SCTP, we took this sort of middle ground on the SCTP support that we weren't going to load the SCTP kernel module, right? And so we sort of tried to be a little bit of half of one and half of the other mode. Like, does SCTP?
That mostly doesn't matter because that's about what pods are doing in their own namespace, whereas this is about what we do with the SCTP packets that are passing through the host network namespace, which we can act on without loading the SCTP module.
My concern was whether there would be a side effect of like doing anything contract SCTP related that might break user space SCTP.
The only thing we can't do is open a socket. We can do anything else with SCTP.
I think we're conflating multiple things together. Pod life cycle, service life cycle, connection life cycle.
Absolutely.
So the answer is different, depends. Even TCP, there are no guarantee gonna get RST or FIN or whatever, and that's why keep alives are configured and.
But you will always have two-way, right?
Yeah, but
you will have the window update that goes back and say,
yes,
I'm blocked, don't send. So there is traffic going both ways.
Yes, and UDP, if you decide to use UDP, you are consciously saying that I have an upper level app protocol where I expect an ACK or whatever. So even with TCP, by the way, like the fact that this thing works is astonishing. Just to set that, like I said it, yes, the fact that TCP works most of the times is actually astonishing. If you read the specs and the way connection teardown and RST and FIN and all this entire dance and all those things expected to work. Yeah.
So Lars had a pretty good answer. You set up a completely new 5-tuple, right? And you have a fairly large space on that, and the old one will die. Sometimes a nice death and sometimes a painful death, right? Yes. I think it's 6 hours it can stay in the contractor today.
Yeah. So is the answer then SCTP should taste more like TCP in this regard? It does have a protocol level termination.
Yeah, I'm just scared what happens. I need to look into it better. I think, I mean, Lars might even know the combination of encryption and connection state. Is it as in TCP where you actually can see it from the outside? or is it not there? Can I see the state changes in an encrypted connection, or can I just see that as packets going back and forth?
I don't
Okay.
know that if you ask me.
I don't know it either. I think we'll have to to look.
Okay. Dan, was there a bug number that you want to send everybody to?
Not quite yet, but somebody from Red Hat's going to file an issue or a PR, and we can follow up the discussion there.
Yeah, I'll do it.
Yeah, there's Surya. Good. Okay, thanks, Surya.
And SCTP does have states, at least on contract. You can see the established shutdown ACK, which is same as the FIN-ACK in TCP. The only thing that's confusing for me is what Per was saying about reset being sent or when a timeout.
Like if you have the ACKs, then it's really, do you still see them in a? I guess you will. Yeah, okay. That case, you should be good. Then you should be able to treat them as TCP, and we should check it out.
I like the idea of adding a test for TCP with a client bind port and see what happens.
Yeah, there was an issue about that when a client only had like 4 ports to use. And it hammered like crazy on those ports, and the invalid entry stayed, of course.
Yeah.
I can't find it now, but I will try.
I remember that one vaguely.
I don't know if it was solved or if it was just abandoned.
I mean, so to bind the port works fine. The question is just to guarantee the uniqueness of the connection, so you don't get the local stack to go nuts on you.
Well, it sounds like we're reaching an end on this one. I think we should move on to Surya and Dan Winship.
Yeah, so Surya was doing internal traffic policy in OV and Kubernetes. She asked me to deal with this topic because it's 11 p.m. there and she's half asleep. But so the big question came down to whether node port connections are internal or external. And in particular, if a pod connects to a node port on the same node, is that internal or external? And if a pod connects to a node port on a different node, is that internal or external? And the answers seem to be awful. And because with external IP and load balancer, no matter where you connect from, if a pod connects to the IP, it gets redirected and it's treated as an internal connection, not an external connection. So you would sort of expect node port to work the same way. And it can work that way when you connect to a node port on the same node, but when you connect on a different node, like everything falls apart and it gets treated as external, which seems extremely inconsistent, but at the same time, it's not clear how you would make it work any other way. So we just sort of wanted opinions, like, is the right answer that node ports behave inconsistently? Or should we just say internal traffic policy actually only applies to pod to cluster IP traffic and not anything else? Since that's sort of the canonical use case. Although that still leaves open the question of would external traffic policy apply to these connections if they weren't internal? So that might not really be an answer.
So my gut feeling, I read your questions before the meeting and I chewed on them for a little bit. My gut feeling is they are external. Like if we were refactoring the service API from scratch, we would likely have a different resource, or at least a different stanza of resource for cluster IP and for node port and for load balancers. And each of those would have different policy statements. And so I think internal traffic policy would only apply to cluster IP traffic. Now, I haven't thought through the implementation implication, but that's where I would default go. And I see Bowie said the same thing on chat. Is there a reason that would be wrong if you've looked at the implementation?
So, okay, wait. So pod to node port on the same node, you're saying is external?
Yes.
Okay.
Yeah, my reasoning is like from a use case perspective is that the person opening up the node port probably is not thinking about internal traffic.
Right. Okay. So, but currently, if you do pod and connect to a load balancer IP or an external IP, that's treated as internal, not external.
That seems broken. Like I know the code path that you're talking about there, but that seems broken.
Can you repeat that? Sorry, the last.
So, okay. So the difference between internal and external traffic policy is where the client is. It's not about how they connect. It's about who the client is. So when a pod connects to anything except a remote node port, it's treated as internal traffic.
That includes going through an external load balancer and back.
If you have the GCP Azure kind of load balancers where we know the IP and short circuit it, yes.
Wow.
Why is external node port?
I think it's about intention. It's like when you are making a decision to open a node port, it's to bring traffic in from outside. And so I think from an intent point of view, it would be different than internal traffic policy.
Yeah, but when you talk about topology, you talk about locality.
We're not talking about topology. Don't talk about topology. It's confusing enough already.
Sorry. Then, okay. I went to the next. Okay. That's the intersection between topology and policy. Okay. I can. So
Tim, I get what you're saying, but that's the opposite of how we defined internal versus external so far. Like right now, it's about who the client is, not how they access the service. So we could possibly change that, especially for internal, although I mean, external traffic policy has been GA forever, right? So I don't know if we can change that.
And don't we have a weird corner case? Is this the same corner case with external traffic policy and node? Like node port's the thing that falls in the crack all the time, right? Does that trip this up also?
I'm not sure what you mean.
Like if I set external traffic policy local and I go to another node's node port, is that external traffic at that point?
Yes, that's where this problem started. That your node's node ports are, if you connect to it, it's treated as internal, but somebody else's node ports are treated as external because it doesn't recognize the source anymore at that point.
But if it goes through the load balancer, it's still internal. That's broken.
I agree that I think that's broken. I think that like as we're staring at how to slice up the endpoint assignments and the policy decisions within that code path, we should be clearer about these ones are internal, these ones are external.
If we want to change internal versus external based on the destination rather than based on the source, that would actually simplify the code a ton. But it means then that you lose the case of the node can connect to the load balancer IP and not have to worry about whether there are local endpoints or not. I guess that's a special case.
And it also requires that there is no address translation, right, and stuff like that. I wouldn't be surprised at some point if you see things for v4 would use map T to map it to a v6 address and then map it back, and all these things to use the sources to classify, unless you're on the node where that source is
right. But that's the thing. If you're not on the node with the source, then it's external either way, right?
Yeah, no, exactly. I mean, then you could solve it by, I mean, having some way to add metadata, right, in the packet when it goes over. But I mean, we cannot require that sort of behavior.
Right. So there's the one classic corner case for same node port, which is the local host thing that doesn't work in IPVS but does work in IP tables unless you disable it. And that's like, I want to access a local host registry or something, right? That's the one use case that I've seen for this in the past. Would that break if we changed same node port to be external traffic policy instead of internal?
Yeah, the problem is that people is using node ports to access local services on the cluster.
I mean, presumably somebody who is connecting to node ports over a local host would not set external traffic policy on their service, right?
But in general, I mean, you can see manifest there that they create that charm or whatever, and they install and they connect to the node port in the same cluster. So we have a lot of this.
But in the same cluster. But what I'm saying is, today, if I get my pod status host IP, right? Node IP.
Yeah,
and,
it's there.
And I connect to that on a node port today, that is considered internal traffic, not external traffic.
And why did you consider that traffic external?
I think we just didn't think about it. I think this is a corner case that we didn't recognize as different. I would have expected it to be external because it would have come into a node port. Therefore, the intention would be I'm publishing it outside of my node.
I think that, I mean, I don't agree with that, but because that is assuming that node port is only accessible externally.
It's not that it's only, but that is why it exists.
Yeah,
right?
but that we are dealing with the problem of what the people did. No,
the problem was current, according to how things are described. It's not that we misnamed the thing and documentation clarity will fix it, or some big note somewhere. It's the intent is broken. So either we treat all internal as internal or all external as external. But right now, like the idea that if I am a pod sitting on this node talking to a node port on another node, I'm considered external. But if I go through the load balancer and back, I'm internal. Is a broken behavior. It's like, so I don't mind if we have the wrong behavior. That's fine. Like if we have a behavior that's called internal, but we call it external, that's fine. We can explain that. But
so here's what I'm thinking though. The fact that it's different whether you talk to a local node port, same node port, or a different node port seems like the big red flag. Like it shouldn't be different. The load balancer, that just feels broken. And I think we can justify that that is in fact broken. I mean, especially because it's different on different implementations, right? On a proxy-ish load balancer, you don't get that. And so then the question is, if we're going to fix the big red flag here, which way do we fix it? We can't say that node port traffic to a different node is local because you can't preserve client IP. So therefore it has to be considered external, right? Ergo, I think we should say same node port is also external. And we bring consistency to node port. We fix the glitch on the load balancer IP and tell people it's about your intent. There's a long-standing to-do also in there somewhere that says, should we apply the load balancer source ranges to node ports, right? So like there are policy things that apply to load balancers, but not node ports that we have historically, not come back and fixed either.
Although I feel like at that point, I mean, at this point, that would count as an API change, right? Like,
oh yeah, I don't think we can fix it now. I think we should just remove the to-do.
So you're saying it's internal based on the source IP?
No, it's internal based on
how it works. But
yeah, because we have it's the what's it, the API, the interface is
local traffic detector.
Local traffic detector. Thank you. Yes.
Yeah, but what happens if my pod reaches the node port in another node with the source IP? The original source IP.
It's external because the local traffic detector says this was not my this is not this machine, therefore it's external.
It's undefined because some of the local traffic detectors, if it made it there unmasqueraded, would still call it local, but it's not supposed to.
The point of, I remember going through this process last year or the year before. The local traffic detector was sort of changed so that, or was introduced so that we could move away from the idea of a cluster cider into, I only really need to consider this machine. So I think the answer is node ports are external, load balancer IPs are external, and that's how our policy statement should go. The only real caveat here is, can we think of a case where that would actually break something that is a reasonable thing to do?
It will break. I just remember that the connection weight thing, node port opener stuff that we were been talking about. That one of it's actually triggered by somebody had like per node the registry cache, and they connect to it via pods and stuff like that. And I can assure you, it's to them, it's localhost. The way they think about it is localhost. I don't know if they have policy on them or not, but I'm quite sure if they put a policy.
So one of the solutions we were thinking about is saying that the whole idea of a pod connecting to a node port is kind of ridiculous, and therefore we don't mind having the ridiculous answer that if you connect to your own node port, it's internal, but if you connect to someone else's node port, it's external.
I don't want to write that doc, man. You can put your name on that blog post.
All right, I'll think about this more and
we need to
send
think
email
about
eventually, I guess, with what I
Okay.
can figure out of what we can get away with doing that won't break existing use cases and stuff.
I have a pretty strong lean on this. Like I'm hard pressed to come up with a case, even a synthetic case, where you would be connecting to a localhost node port and the current policy is important to you.
That's a good point.
Like I just, most people would just not be using policy for that.
I wonder if anybody who's using a multi-tenancy, using hypervisors, container, and so on, what do they do about? What do they expect? Because if they are using, somebody's using like hypervisor container, Firecracker or whatever, and they are running two containers using two different tenants on the same node, and you can loop back traffic. I wonder if they know.
I don't know. Sorry, something last comment, and we move on. I don't know if we have any more agenda, but internal traffic policy is very new anyway, right? So before that, it was either I'm getting, when I talk to a same node port, I was going to get global behavior, cluster scope behavior anyway, because there wasn't a way to specify otherwise, right? So,
well, I mean, if external traffic policy got applied to the connection, then you would get the external traffic policy.
Right. Okay, well, let's see if we can find a use case where this matters. I'm not seeing it right now.
Yeah, I don't think so either. And I know, at least in OvenK, it made external traffic policy a nightmare to have to account for pod to node port. Like, it was an absolute pain, and this would make it a lot easier. So,
quick clarification. Oh, go, Surya, sorry.
No, I was about to say that's because we didn't ask Dan Winship before we implemented that, because Dan Winship's solution where node to a pod to other node is external, it would have simplified things.
I think we got told not to do that, but yeah.
So the short answer here is whenever you have a question, just ask Dan Winship.
That's what we usually do at Red Hat, yeah.
Does it involve some esoteric corner case of kube proxy? Dan Winship's fault.
Oh. Quick clarification for Dan Winship. I had written that second issue there, or second item there, and then you crossed that out and said, but it can't be for compat. But I thought that is exactly what Tim said earlier. Is it just that we can't do that?
I think he was saying that we should have done it that way, but
okay.
At this point, like if we were to change it, like people are depending on the current behavior, presumably.
Oh, actually, I was wondering if pod to LB being considered external is something we could change, but I hadn't thought about the compat issue there. What I was saying was completely broken was we couldn't change load balancer source ranges to apply to node port. Like that would break people for sure.
I guess the load balancer short circuit thing, the big thing that it wants to preserve is that if a pod or node connects to the load balancer IP, when it's on a node that doesn't have an endpoint, it shouldn't be rejected. And it currently does that by treating the connection as local. But I guess it could also, we want to transparently treat it as though the packet actually went out to the external load balancer rather than being redirected. So we could do that without treating it as local, I guess.
Right. I mean, the reason this logic exists in the first place is because on those VIP-ish systems, that's actually a local address anyway. So if we don't handle it, it will go out to the host's network interface and then try to connect to something that isn't running on the host's IP, right? And it will just fail completely.
So we do have one more agenda topic. We got 10 minutes left. So Andrew, I think those are all yours.
I don't need the 10 minutes. It's just I posted a PR implementing or starting to implement the AMP API and associated CRD. So if folks want to take a look, feel free. There's 2 main unresolveds you can still find in the KEP that we want to fix in this API PR. So keep that in mind when you're reviewing. That's all I have though. Thanks.
That's great. I'll definitely take a look. Probably going to start prototyping implementation of it soon too.
Awesome. Thank you.
Yeah, I still want to discuss more about the internal external thing. So, because for me, internal is the traffic that is internal to the cluster. The service IPs, the load balancers IP, maybe not, but the cluster IP, the node IP, those are internal IPs.
So the definition, the way that internal versus external traffic policy was defined in the past is that it depends on who sends it, not where you send it to. So like we're stuck with that pretty much. Like unless we want to deprecate external traffic policy and redo it.
No, it's just curiosity because we were all, I mean, I was surprised everybody here has a different idea. I mean, so for me, that's the internal definition is like when you have an AS or something, is everything that is inside your network is internal. So that's the way
I don't think you're the only one who feels that way. I just read the KEP and changed my way of thinking, to be honest.
No, but I mean, I can. The other points are valid too.
I mean, we have what we have historically defined or left undefined, or implicitly defined via code. But as long as we can convince ourselves that we're not going to break users, we can define it how we think it should be defined, as long as we have reasonable confidence that we're not going to break users, and an escape plan if it turns out we're wrong and we broke them anyway.
Because the origin of this is the internal external traffic policy change that Dan Winship is going to run. No, or well, Andrew.
I'm just fixing an edge case, which Tim, you should go review that PR again, by the way.
Yeah.
Okay. I have a lot of PRs to review. I'm coming out the other side of a long process. So if I talk to a node port on my same machine, then I can apply, I could apply, let me think for a second before I speak. That's currently, we consider that internal. And so we don't apply external traffic policy, right?
Well, are you a pod or are you an outside source? You just said if I talk to a node port.
I'm a pod and I talk to a node port on my node. Then I can preserve client IP because that will work just fine, regardless of whether the external traffic policy or regardless of whether internal traffic policy is cluster or local, right? Because if it was local, it's fine. If it's cluster, it's also fine because the source IP will be like all the semantics are correct, right? If I talk to a node port on a different node and it forwards me off to somewhere else, it's going to, at least in the kubeproxy implementation, it's going to masquerade. So I'm going to break internal cluster semantics. So that cannot be internal, right? So this is how we end up in the gray space, right? Same
Well, it's
node
also a
is internal.
use question, right? Like why, if you're a pod trying to access the service, you should be using cluster IP anyway. You're already in the overlay. Why?
Well,
why
I
are you
mean,
going?
people might have a consistency. They might be migrating, right? They might be going from VM to pod-based applications.
Sure. And we've
Okay.
seen things with people using external service discovery stuff where they just register the node ports.
Yeah.
Okay.
So there are reasons people would end up here. They're not great reasons, but there are reasons.
Okay, fair enough.
I'm just gonna have to think about the use cases. I can't come up with a good one.
You come back to, is it better than just to describe the existing semantics and describe it with its warts and live with it and then fix it in a new generation, or try to fix it?
Let me ask a separate question. We know the kube proxy implementation well. What about other implementations? Do they retain the same behavior, or do they implemented internal differently?
So I can speak on the IPVS one a little bit. Like, it takes a more naive approach where it considers like the load balancer IP and external IPs to be always external, even if you hit it from internal. And it always considers like cluster IP internal. So it actually just does it based on the use of the IP and not the source. But that also has led to like a lot of people complaining about like if you create a load balancer and you set external traffic policy to local, but then you want to use that same IP from inside the cluster, then your packets get dropped if you land on a node that doesn't have the endpoint, which complicates it.
But I mean, that last part should be treated as separate from the question of internal versus external. Like, if you connect to a load balancer IP from a node that has no endpoints, like it should, we should just forward it to.
Yeah, like the problem is that people assume that if I connect to this load balancer IP from inside my cluster, it should route out to the load balancer and back in. But the IPVS rule binds on the network stack and it intercepts it before it even leaves, and then
right. That's the same as the VIP load balancer behavior, right? And the assumption with external traffic policy local is that your load balancing stack will not send you to a node that doesn't have endpoints so as to avoid the black hole. So in this case, if you are a pod on one of those nodes, you are subject to that black hole. And so maybe that's the reason that same node is internal.
So it seems like if you send to a bad node, a node with no endpoints, if it just treated the service as though it was cluster, that would have no externally visible effect. Oh no, because there's the problem that the load balancer might be slow to catch up with endpoint changes and might send. Okay, no, never mind.
Andrew, is there ever a resolution to those issues? Or do we just tell users they're holding it wrong?
Yeah, I don't think we've ever fixed like if you connect to a load balancer IP on the pod and there's no pods on that same node, like that traffic is still dropped. And there aren't a lot of, like, we've discussed workarounds of like defaulting to IP tables for that kind of case, but like they all seemed really hacky. Like, it's really hard to work around the fact that you have the IP binded on the IPVS stack.
Mm-hmm.
So yeah, that hasn't been resolved.
I mean, you could maybe do crazy crap with policy routing to send it out a different table.
Yeah.
Somebody erase that from the recording, please.
At that point, it seems like it would be easier to do like, split horizon DNS so that your local pods get the cluster IP instead of the load balancer IP.
For IPVS, there is an open issue on this, or it's a pull request actually, with the implementation of a very simple solution.
I thought I remember this.
Can you describe the solution if you know?
Find it then.
Okay, well, we're at time. maybe you can link it to the mailing list or something. Or Dan, do you have an issue where you're discussing this? There we go. All right.
Also, just one quick thing. Can we have a decision node where someone is going to start documentation where we discuss more? Because the way OVNK does is we ask, what does kubeproxy do? And it would be good to get some of these things explicitly defined in a documentation for kubeproxy so that we can just point users saying upstream does it this way. That's why we do it this way.
Yeah, we should get a clear state.
Yeah, I'll submit an update to the big doc in the Kaping repo of how kubeproxy works as well.
Thank you so much, Dan.
All right, I'll go read the issue that Lars just linked. Thank you. Fun topic.
All right. Thanks for coming, everybody.
Thanks all. See you in 2 weeks.
Thanks. Bye.